Ja, jag har pratat med honom.
Hör ni mig?
Okej.
Ja, vi hör dig bra. Hej Peter.
Bra, hej.
Hej Peter.
Välkommen. Lite short introduction. You are, like I said earlier, working a lot with Saab problems.
Yes, and in many years I worked together with Peter Bergström at Saab Kockums, implementing the PLC standards, and he is very much more than me working with building integrations, but he is also a very good expert in the PLC standard. So it's very helpful to have him here. So maybe Peter, you can use
your phone. Your phone.
Is that the one pausing?
Okay. Yes. So maybe you can do a very short introduction of yourself.
Yes, I'm working at Eurostep, but currently, since almost 10 years, I'm working almost only for Saab Kockums as a consultant with the architecture and an architecture for the PDM implementations. And before that, I have been working with PLCS, held a lot of trainings all over the world in PLCS. I didn't participate in the actual development of it, but I have learned after the fact, so to speak. And I was at one point also working in ISO with the file formats used for transferring PLCS data, part 28. So I have done some international standardization work, but nowadays I'm only working with Saab Kockums.
Okay, thank you.
Yes.
So,
Peter will participate and go in more in detail in some of the slides here. Yeah. Okay, this figure illustrates the chip life cycle management, the test case 2. And as you see, most to the left, you see the different levels of abstraction of USM. And then we see the model track, and you see the and here you see it's an early picture with the misunderstanding that they were isolated at each level that I corrected in my last picture, that all the different model fits together. So it is one model of URSM with all the different sub-models included. What we can see, URSM is about standardized how we transfer and define models. That is where the meta model in URSM plays a really critical role. And this model is then detailed in the smart manufacturing reference models. And this example are the SSEF model that is used as an input to the JVG 2021 work. And at the enterprise level, you have the enterprise management system that take care of who you work with these different things. For example, development models, lifecycle models, and similar. And at the bottom, we have the reality with the operational IT environment and the real softwares and the real data in the data systems. On the right side, we have the semantic track, where URSM starts with its top-level concept model, defining who it is the format for how do we define concepts. And it's very much based on the semiotic triangle. Then PLCS is more detailed, and here is PLCS concept model that we used on Kockums because we implemented the PLCS very early. but we realized quite soon that these terms and concept definition was at two abstract levels, and they must be, because PLCS aims to be across a lot of different contexts, and that's why it needs to be at a more abstract level. But when we take it down to the implementation model, to a specific company context, the people that didn't like these abstract begreps, concepts and terms, so we need to specialize the concept and terms to a language that fits the people that working in Kockums, to make they understand their information. That is a very important step for each company, to create a concept model that reflects the language that they use in their company. And I have example later on with degree of detail this concept model needs to have, because it cannot be too detailed. It must be enough detail. Yeah. And at the bottom is the data that is defined based on the concepts that we use. And it is very needed, because when we transfer data between different systems, they have very much specific definition what they mean in each system. So when we're building an integration between two systems, we need to have this more abstract level to translate between the different definitions of concept in different systems. That's the way they fit together. So, and a little bit about our context. Shipbuilding is products with extremely complex products with very long life cycles. And the thing in the IT department for a shipbuilding company is that every ship project, when it starts, it also starts with the most modern IT environment that you have when this generation of the ships. And then, so as long as the ship lives, the IT environment for each generation of ship continue to live within, because it is very difficult to move the information from the old software to the new software. So that's why we have a very mixed up set of different software with different generation of information from different ships. So here you see some of the most important, and there we have the Bergström corvette, and now we have the next corvette that we are starting with now to specify. It will be produced within maybe 5 years. So it's a long time to production, but we need to create a lot of information during this phase here. So that's a little bit of, and you see up there the different times. So, and this pictures is from open presentation that we had on conference product data PDT, Product Data Technology Europe 2015. So this presentation is an open presentation, so that's why I can use the figure from that presentation, and it represents what we thought about after the PLM project, that we should work in the future with information at in particular in Kockums. And what you see, you can see we indicate here that information about the pump is in a lot of different sources. It says functional models of the pump, how it physically will be installed in the ship, where it will be mounted, the physical individual pump, the pump in the spare parts catalog, the design of the pump. All these different views of the pump are stored in different softwares, and we need to have a comprehensive view of the pump, not a lot of different views. But as I said, it is stored in a lot of different software, and that means without standardized software, the information is really looked in the different software. And that is a big mistake from the software industry, that they did not introduce and use open standards for accessing the information in their software. They're looking their software in. And that needs to be changed in the future. We have a very good standard to doing this, because we have the PLC standard and the software we call the backbone, where we implemented the PLC standard, because the PLC standard is such a comprehensive standard that it covers the data for the complete life cycle of a product, even a complex product as a Navy ship. And here you see examples of some related software that we used at these days when we at the PDT Europe presentation. Not all software, because I think it's about 25 software to managing the information per ship, isolated, without an integration by a standard like PLCS. So, as I told you, the PLCS concept model is at a very abstract level. So to make it make sense on the shipyard, first of all, we have this representation of our architecture principles on Carlsson. We call it the information pyramid. But the foundation is, if we do not have control over our concepts and terms, we have not control over the data and information. And if we do not have control over the data and information, the process is not working very well, because they work with the wrong information and data, and maybe even not accessible. And in the organization is the people that working in all the different kind of tools, depending on the expertise that they're working in. So they need to have tools where they access the information needed in an integrated way. And tools is unfortunately the top of the iceberg, because this is the only thing that people in the organization see. They say, give me a better tool, give me a new tool. It's not a question about a tool, it's a question about all these bottom levels. Just changing a tool do not solve the problem. That is very important, that this is the top of the iceberg, and everyone is just discussion of the kind of software they would like to use. No. So if we take a look at the concept model, you see these gray boxes up here over each column. That is the different domains of knowledge. For example, we have the business related here. We have area information management, we have sales, we have project, we have procurement and supply. And if we do not have all the disciplines, it is the disciplines that is very much related to the procurement of and management of the products. And here we have the different design disciplines, from concept development, requirement, conceptual design, basic design, detail design, production information preparation. Very important to transfer the design information into production package. It's very difficult. And we have the production, test verification, and then true life support. It's a quite simplified picture with the, of course, it's more disciplines, but we need to simplify and do it detailed enough. And here we have the engineering support with part management, configuration management, and support system definition. So you see we have around 15 knowledge domains, and that's quite normal. It's good enough, 50. But when we're talking about the USM, the language here is that this should be a dimension, and this is what we call aspects. And aspects relates to the concepts. That means that we have not a one-dimensional model, not a two-dimensional, not a three-dimensional model. We have a 15-dimensional model, but with not so much concepts in each. It's not more than 10 concepts in each expertise domain. So you have to find out in the same way what kind of expertise domains do you have in your company, because there is there where they can define the concepts that they need to share together, because each expertise domain have, of course, a lot of very much detailed concepts, because that is the expertise domain to master its detailed concepts, because that's what they learn. But maybe this concept is not what they have to share with all other disciplines in the company.
Ulf, Peter wants to.
Yep. Peter.
Yeah, I tried to comment what you said earlier, but I was muted, so I thought there was a reason.
Good.
Yeah,
But
there was some sound issues.
Yeah, I wanted to
Go
say
ahead.
that at Kockums, when you presented the first pictures, it sounded like we started at the top from the URSMS and whatever, and went down. But we actually started with the bottom layers here, and then so the concept model was one of the first thing we did, because we wanted to have a better integration between the internal systems, and then we had to find out what do they mean with a part and a unit and a product and so on. So we started at that end, and then we tried to. And there is some funny things going on with the sound here. If you can hear me, then we tried to apply PLCS to that concept model. And in doing so, we had smaller modifications of the model, and then we moved up the steps instead. Sorry, I'm finished. Unmute här.
Jag tänkte vi har två slides. Den här första this first slide provide an overview of what is the Kockums specific content that we added to the URSM structure. And I think Peter, who is really working with this, can explain a little bit where we see the PLCS concept model, the PLCS information model, and backbone XML. So Peter, can you explain how these models, where they are and how they relate?
Yes, to the upper right there, in the top level, you have the PLCS concept model, which is a simplification of PLCS. PLCS has, I don't know, 500 entities or something. And here you see only 25 maybe. So it's a generalization of what's in the real PLCS standard. And the colors there are made to categorize them as being part of part information or activities or things like that. And at the bottom of the model, there is also other colors for helping entities and so on. So that concept model is mapped to the URMSM model in the purple box that you see there. And from, sorry?
No,
okay. And from that conceptual module, we have the PLCS standard on the SMIM model, I think. In integrating the SMIM model, the information model, when we map it to the concept model, we use the PLCS templates, because a template in PLCS contains a lot of entities needed for capture all the information about a part, for instance. The part is just an entity, and the part version is another entity, and so on. So the templates are basically things that we have grouped a number of entities together to express the concept of a part. So that template is basically used for saying that this information model adheres to the conceptual model by the template. And at the bottom right, you have the backbone XML file that was developed 10 years ago, maybe, at Kockums. It's an integration format for the data, and the idea was that it should be IT system agnostic, so it should not be particular to any of the systems we use, but it actually has a different schema for each concept. So one concept in the Kockums conceptual model is one schema in the BBXML, and then you can instantiate an XML file, and of course the attributes that goes with a part, for instance, is we have to select what attributes we think we would like to expose when we integrate data between systems. And for each of those attributes, we have to ensure that we have a correct mapping from this BBXML to the actual IT system that adheres to what the definition of that attribute is on the concept, and that goes all the way up to URM SM. I don't know if I made myself clear here.
Yeah, that was very good, because now I first switch to how it looks when it's implemented in the URSM ontology.
So, yeah.
And 1 minute now, Ulf.
Yes. Here we are. Because to the left side, we see the UML, the URSM objects, and it's not classes, because I'm not so good in class modeling. It's more like folders, how I would like to structure the information. But we see as an Excel table here, the backbone XML schema that Peter provided me with for this test, where we don't use in the XML schema, we use each row for a concept with the name from the backbone XML, and also the attributes and what PLCS entity is related to it. So it's one of many ways to express who we would like to exchange, because most companies we exchange data with even do not know how to manage XML. That's why very much of the exchanges is about Excel files. So we can also use an Excel template, or we can use any kind of template automatically more or less generated from the URSM structure. Because on the left side, we have the different objects that we use to define the format. So that is very powerful, and that is also show how we implemented the URSM in Protégé as an ontology, and I have to learn about how to manage ontology. It took me some weeks to do this, but think if it's a person that is expert on Protégé and ontologies, what kind of success it should have been. But it's good enough to prove that the ideas behind URSM is really possible to go down to the shop floor and connect to data.
I think that's a great ending of the presentation.